So now let's talk about a cosine function. Really, the very same kind of things that we were saying about our sine function apply with the cosine function as well. This 1/2 that you see here in front of the function is really only going to change what happens with our y values, not our x values. So for our y equals 1/2 times cosine of x, we're going to find that we have all of the same key points that we did for the original cosine function. I'll go back a little bit here. Here it is. For our original cosine function, we're going to use these values along our key points along the x-axis. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'll map those along the x-axis here. And now we're going to look at the y values. Now in the y values, what happens is that we could take each of the y values that we normally might have had from our cosine function, which would 1, 0, -1, 0, and 1, only this time we're going to put them, multiply each of those values by 1/2. So instead of going through 0, 1, we're going to go through 0, 1/2. Instead of passing through pi over 2, 0, well, it's still going to be pi over 2, 0. At pi, it's not going to be -1, it's going to be -1/2 now. At 3 pi over 2, it's not going to be 0. Well, it is going to be 0 there. 2 pi, we're going to go back up to positive 1/2 this time. So if we want to do a little bit of a comparison right here, here's 1/2. Here's -1/2 along my y-axis. I'll compare that. Here's positive 1. Here's -1. So if I were graphing my cosine function, I'd go 0, 1, 0, 1/2, pi over 2, 0, pi -1/2, 3 pi over 2, 0, and 2 pi back up to positive 1/2. And so one cycle of my graph y equals 1/2 sine of x will look similar to this curve right here. You're going to be careful to try and make it look just about right, but I think this is okay right here. We go. All right, so one cycle of the function would look like this. And again, just kind of for comparison's sake, here's what that cosine graph normally looks like if we follow along its pattern. And you'll see that this looks like it's a compression by a factor of about 1/2. So comparing it to our original function, that's what we've got. All right, not too bad. What would happen if we have a negative in front? Well, for sine or cosine, what that negative tends to do is it changes the direction of the graph. So each of the y values that we normally would have had for our key points within one cycle, 0, pi over 2, pi, 3 pi over 2, 2 pi, the key points are still the same for that one cycle. The y values will change, though, by taking each of the y values that we would normally have gotten and multiplying them by -3. So our y values are going to go 0 times -3, which is 0. We're going to have -1 times -3. That's going to become positive 3. 0 times -3 is still going to be 0. 1 times -3 is going to give us -3 this time, and then back to 0. And so for comparison's sake right here, here's 1, 2, and 3. Here's 1, 2, and -3. And the key points along the x-axis. As we plot this out, we go through 0, 0. At pi over 2, we get -3. At pi, we get 0. And at 3 pi over 2, we get positive 3 this time. And then at 2 pi, we're back to 0, and our cycle would repeat again. We're going to get a curve that looks similar to this right here. Passing through each of these points, you'll notice that the direction it takes is different than what happened when we had our original sine function, in which the graph started by going in the upward direction instead of the downward direction. But all that negative sign changes is the direction. Our amplitude, we find our amplitude by taking that -3 and taking its absolute value. Remember, an amplitude is a distance. An amplitude tells us the distance from the center axis to the highest or lowest point. So that's still positive. The period is still 2 pi. That hasn't changed. Our domain is all real numbers. But our range has changed from -3 to +3 instead of -1 to +1.